In the next example, we can see that we no longer have the x plus y inside of the parentheses. We have a plus 2. That doesn't change anything in a meaningful sense for us in terms of how we're going to build the initial stage of our binomial expansion. It's just now the first piece in the set of parentheses is a instead of x, so it's going to get the x treatment. It's going to start from the exponent that we see on the outside here, so it's going to be a to the fourth in the first term, and it's going to go down by 1 every term. And then this time, instead of having a variable like y as the second term, it's a number. So it's going to be 2 that's going to be in that second position in each of the terms. So starting from missing in the first term and then counting up. But then we're still going to use the coefficients from Pascal's triangle like we did in the previous examples, so we're going to be going to row 4 eventually. So if we want to start building the expansion here, I'm again going to start with the blank here, and then my first term is going to have the a to the fourth, so that first piece in the set of parentheses raised to the exponent on the binomial, and then the second piece, the 2, is missing. So then the next is going to have the coefficient, we'll fill in just a moment. It's going to be a to the third, and then it's going to be times 2, instead of a variable like y, times 2 to the first power. And then the next term, leave space for the coefficient. A is counting down, 4, 3, we're down to 2. And then this time the second thing in the parentheses, the 2 is going to be raised to the second power, so that's counting up. So one more time, we've got the blank there for the coefficient. We'll fill in momentarily. It's going to be a to the first times 2 to the third power. And then finally our last term has no a in it, but it has 2 to the fourth. And so now if we go to row 4 in our Pascal's triangle here, we've got 1, 4, 6, 4, 1. So if we go back here, I'm going to fill those in. 1, 4, 6, 4, and 1. Now, on the previous examples, at this point we were finished because we had just variables inside the parentheses. So there was just variable terms, as we see here, x third to the third, y squared, x squared, y cubed, and so on. But now, because we have a number as the back end of our parentheses, so as part of each of these terms, we have to multiply everything out by that 2 and the coefficient that's out in front. So we have to just simplify each of these terms. So if we start here with this one, right, so we've got 1 times a to the fourth, well, that's just a to the fourth, nothing much going on there. For the second term here, I've got this 4, and then I've got times a to the third, and then times 2 to the first, which is just 2. So really I have 4 times 2, so I'm going to clean that up and make it 8a to the third. For the next term, so here we've got 6 times a squared times 2 squared. Well, of course, 2 squared, this here is 4, so I've got 6 times a squared times 4, or 24a squared. For the second to last term here, I've got 4 times a times 2 to the third. Well, 2 to the third is not 6. Don't make that mistake. It's 2 times 2 times 2. So that's going to be 8. So I've got 4 times 8, which is 32. And then there's still the a as part of that. And then for the last term, we just have 1 times 2 to the fourth. Well, 2 to the fourth, don't say that's 8. It's 16. 2 times 2 times 2 times 2. We end up with 16. And so here then is our expanded binomial. So it's just a little bit different when we have a number as that second piece in the parentheses rather than a variable. It still gets treated the same way, where it's missing from the first term, raised to the first power, raised to the second, raised to the third, raised to the fourth. But now, because it's a number, I need to simplify each of those terms by multiplying out the exponent and then multiplying whatever I get times the coefficient for that particular term. The next one has a little bit of a different challenge. We again have a number on the back end here, just like we did in the previous question. So instead of a 2, it's now a 1, but it's going to get the same treatment. But the first piece now isn't just an x or an a like it was in the previous question, but now it has a coefficient in front of it. So the entire first piece of the set of parentheses is this 3x. So when we apply the exponent, starting from the 3 that's on the outside and work our way down, it's going to be applied to the entire 3x rather than just the x. So to see how that works, so we'll expand this one. We're going to leave it blank. Then we're going to have 3x that's going to be raised to the third power. So it's whatever occupies the first piece of the parentheses that is going to be raised to the exponent that we see on the outside of the binomial. So we've got 3x to the third, and then the 1 doesn't play a part of it. Then for the next term, it's going to be 3x in parentheses squared. So we had 3x to the third in the first, now it's 3x squared, and then times just 1 to the first. So that's nice. The 1 is not going to play much of a role here. So then for the next term, we're going to have 3x raised to the first power. So we've gone from the third power down to the second power, down to the first, and then we've got 1 squared. And then we finish things off with, again, a blank there. The 3x is now gone, and then it's just 1 to the third. And so to grab our coefficients from Pascal's triangle, if we kind of clean house here a little bit, so we can see row 3 is right here. So my coefficients are going to be 1, 3, 3, and 1. So if we go back, I can fill those in 1, 3, 3, and 1. And so just like we had in the previous question, I've got some simplifying work to do. So for example, on this first term, I've got 1 times 3x to the third. So I need to make sure that I multiply 3x times 3x times 3x. So 3 times 3 times 3 is going to give me 27, and then x to the third. And then since I had a 1 coefficient out front, that doesn't change anything for me. For the next term, I need to multiply 3x squared. So 3x times 3x, so that gives me 9x squared. And then I need to multiply that times the 3 that I have out front here. And then since we're just multiplying by 1 on the back end, that doesn't really play a part. So I've got 3 times 9x squared, so we get 27x squared. For the next term, a little bit easier, I've got 3x being raised to the first power, so that's just 3x. I just need to multiply that by the 3 that I have out front here, and then 1 squared is just 1, so again that doesn't play a part. So I've got 3 times 3x, so I've got 9x as the second to last term, and then finally it's just 1's all the way around over here. 1 times 1 cubed, so it's just going to equal 1. So we've got our answer here. So the difference in this case is we had a variable and a number that made up that first term. So 3x, so that got the full exponent treatment. 3x to the third, 3x to the second in the next term, 3x to the first, as opposed to just having that variable hit by the exponent.